As promised last week, in this video I'm going to talk about the relationship between autism, ADHD, and epilepsy, including reviewing a couple different types of genetic syndromes that have epilepsy as a primary feature, but that also have relatively high rates of autism. First off, though, let's define what seizures and epilepsy are. Seizures are sudden, temporary bursts of abnormal electrical activity in the brain that disrupt the way neurons normally communicate with each other. Seizures can be focal, which means they're limited to a smaller area on one side of the brain. Meanwhile, other seizures can be generalized, affecting both sides of the brain simultaneously. Epilepsy, on the other hand, is the chronic propensity for having unprovoked seizures. Now, not all seizures necessarily lead to epilepsy. For instance, someone with a brain infection like meningitis or encephalitis may experience seizures, but those seizures may go away once the infection is hopefully resolved. Another example is a person who has very poorly controlled diabetes, and they may be at risk for seizures when their blood sugar goes too high or too low. Therefore, while all epilepsy involves seizures, not all seizures lead to epilepsy. The symptoms of the seizure really depend on what parts of the brain are affected. For instance, if you have seizures that involve your temporal lobe, you may experience sudden and intense emotions or have various visual, auditory, smell, or taste-related hallucinations. Memory is also often affected in this type of epilepsy because the temporal lobes house a structure known as the hippocampus, which is really important in forming new memories. Seizures that involve the frontal lobes tend to be pretty brief in duration, usually less than 30 seconds, and they can cause speech problems, some motor problems like thrashing of the limbs, or they can lead to bizarre or inappropriate behavior. If the seizure happens towards the back of the frontal lobes, where the motor cortex is, then the person may have rhythmic jerking or twitching of various body parts, and that jerking or twitching can actually move along the body in what's known as a Jacksonian march. Alternatively, motor cortex seizures may lead to weakness or paralysis. If the seizures occur in the parietal lobe, the person may experience tingling, numbness, burning sensations, vertigo, or even body image distortions or distortions of visual and spatial perception. As an aside, I know some of you who have Ehlers-Danlos, fibromyalgia, POTS, MCAS, etc. may suddenly be wondering if you have seizures, since a lot of these symptoms sound familiar. I know my mind went there too. Along those lines, if seizures happen in a location called the insular cortex, it can cause autonomic symptoms like changes in heart rate and blood pressure and digestion. So yes, that's an interesting overlap that could probably do with some additional study. Anyways, what do we know about the rates of co-occurrence between autism and epilepsy? There was one study by Amiet and colleagues back in 2008 in which they performed something called a meta-analysis, where they collected together a bunch of similar studies and analyzed them together en masse. From this meta-analysis, they found that epilepsy occurred far more frequently in autistic people who also have intellectual disability, or ID, compared to autistic folks without ID. They found that over 21% of autistic people with ID had epilepsy, compared to 8% of those without intellectual disability. What's more, the risk for epilepsy increased the more severe the intellectual disability. Now, I should point out that the 21% epilepsy rate in autism with ID is actually almost identical to the 22% rate of epilepsy in intellectual disability in general. So that doesn't dramatically differ from what we would expect for intellectual disability overall. Now, if we look at the rates of epilepsy in the general population, which is about 1%, compared to the 8% occurrence rate we see in epilepsy in autism but without ID, epilepsy is obviously 8 times more prevalent in that autism group compared to the population as a whole. So next question, what about sex differences? While the Amiet et al. 2008 study didn't separate out sex by IQ, they did look at sex as a predictive factor, and they found that epilepsy was almost twice as common in autistic women compared to autistic men, at 34.5% versus 18.5%. Now, in the general population, we actually see men affected with epilepsy slightly more frequently than women, but this may at least be partly attributed to the fact that males are more likely to acquire traumatic brain injury, or TBI, as a result of more risk-taking behaviors, which in turn may put them at higher risk for developing epilepsy following brain injury. In any case, we don't really see that female heavy epilepsy rate like we do in autism. Women are also more likely to experience more significant fluctuations in seizure activity, regardless of whether they're on the autism spectrum or not, thanks in large part to dramatic monthly changes in hormone levels. Many women, for instance, experience a worsening in their epileptic symptoms around the time of menstruation. Meanwhile, the relationship between ADHD and epilepsy hasn't been studied quite as much as we see in autism, but we do see that about 2 to 3% of folks with ADHD do develop epilepsy. On the flip side, ADHD symptoms are very common in the epileptic population, affecting up to 1/4 of people with epilepsy. Unfortunately, we don't have very good information on whether there's sex differences when it comes to epilepsy in ADHD, but presumably women with ADHD and epilepsy share a similar profile as women without ADHD, and they experience significant fluctuations in their epileptic symptoms around the time of menstruation. Okay, so those are the basics of epilepsy, and specifically epilepsy in autism and ADHD. But what about rare genetic epileptic syndromes that have a strong association with autism? One classic example is called Dravet syndrome. This condition is a really severe form of epilepsy that typically begins during infancy. About 70 to 80% of people who develop Dravet syndrome have mutations in the SCN1A gene. Now, if you watched my video on migraines, the SCN1A gene may sound familiar because it's also mutated in a type of familial hemiplegic migraine, or FHM type 3. In FHM type 3, the SCN1A gene mutations lead to a gain of function, so as a result, the sodium channel that this gene helps to code for actually becomes overactive as a result. Since this gene is largely expressed in inhibitory neurons, that means they tend to do their job too well in regulating excitatory neurons, and that leads to too much inhibition. On the other hand, SCN1A mutations that are associated with Dravet syndrome are loss of function mutations, which impair those inhibitory neurons' ability to regulate excitatory neurons, and that ultimately leads to seizures. About 90% of SCN1A mutations that are associated with Dravet syndrome are de novo, or new, and most of the time they've arisen in the father's gamete, aka the sperm. Now, one of the curious features about seizures in Dravet syndrome is that they're often sensitive to body temperature. For instance, many children with Dravets will have an onset of their condition following an illness or vaccination, both of which may lead to fever. However, many people with Dravet syndrome will also be more susceptible to seizures when they have an increase in their core body temperature, so they have to be careful about heat exposure, such as being out in the sun too long or even taking a hot bath, either of which can trigger a seizure. Although scientists aren't entirely certain how this happens, the same sodium channel is also expressed out in the peripheral system out in the body, and it's been shown that this channel's function is definitely sensitive to changes in temperature. Now, another genetic syndrome that frequently features both epilepsy and autism is a condition known as Angelman syndrome, or AS. Epilepsy occurs in about 80 to 90% of people with AS, and autism is seen in about 30% of those people. This syndrome is linked with the Q11-Q13 region of the 15th chromosome. About 65 to 75% of people with AS have what's known as a maternally derived genetic deletion that includes quite a few genes in that region. Basically, that whole region is just kind of deleted. Meanwhile, about 7 to 11% of AS cases don't have that type of deletion, but instead they have a mutation in a gene in that region known as the UB3A gene, and that causes a loss of function of that gene. This gene in particular is central to Angelman syndrome, although deletions that include additional genes can lead to more severe medical problems. So, for instance, while the majority of people who have some kind of loss of function of UBE3A develop epilepsy, whether that's because because of a mutation hitting that gene or just a deletion of that gene. But for people who have those genetic deletions that also include another nearby gene known as GABAB3, which codes for a part of the GABA A receptor on inhibitory neurons, these people tend to experience even more severe forms of epilepsy than people who only have that mutated UBE3A. Now, in addition to epilepsy and autism, folks with AS tend to have relatively severe intellectual disability, speech and language challenges, problems with motor coordination, and unusually, they also tend to have a very characteristic happy demeanor. This is actually something that is almost diagnostic of these people. So now I want to say there are many, many, many more genetic syndromes that share associations with both autism and epilepsy, enough that honestly we could fill a book with them. So we're only covering a couple classic examples in this video, but just be very aware that this is just the tip of an extremely large iceberg. So if you would like me to talk more about these genetic syndromes that associate with autism, intellectual disability, and epilepsy, definitely feel free to let me know in the comments. In any case, I hope you've enjoyed this cursory dive into the topic of autism, ADHD, and epilepsy. Let me know in the comments what other topics you'd like me to cover in future. And in the meantime, please remember to like, subscribe, and share. And thanks again until our next video. Ciao.